Hello everybody, I'm Nagaraj Harikar from the product development team at Citrix. I have around 12 years of experience in networking and cloud domain. Today we'll understand what observability is, why it is important for any organization, how our Citrix product suite with products like Citrix ADC and Citrix Observability Exporter can address these key challenges with observability, especially for your microservice-based applications. So what is observability? It is a measure of how well we can understand the system from the work it does. So for example, if you see your stitches, you should know if your sewing machine is working correctly. So now we'll see why you need observability. Present day, with organizations of all sizes moving their applications to the cloud, it is very essential that you instrument every component in the cloud infrastructure. Telemetry all the critical data to know how healthy is your system. Observability as an amalgamation of science, art and technology can help achieve this. And we will see how this can be done. So with observability, you need to be paranoid about collecting the data, be smart about interpreting the right data, automate problem detection and resolution so that you're only alerted when there's a real issue which requires DevOps intervention. Now let us see the three pillars of observability. One is monitoring metrics with alerting and visualization. The other is log aggregation and analytics. And the third is your distributed system tracing infrastructure. So in general, we tend to measure data at three levels: the network, machine and application. The application metrics are usually the hardest and yet most important of the three. Citrix ADC, which is a comprehensive application delivery and load balancing solution for both monolithic and microservice based applications, its advanced traffic management capabilities enhance application performance and provide a comprehensive security solution for your microservice-based application. Citrix Observability Exporter, which is a microservice-based application, collects the data from your Citrix ADCs and transforms them into consumable formats suitable for various endpoints like Prometheus, Elasticsearch, Apache Kafka, and Zipkin. Organizations that recognize how important application performance is to their business also face new challenges, particularly if they have embraced cloud-native technologies like containers, microservices, and Kubernetes. Citrix offers two flavors of deployment for observability. One, where we have it bundled in our Citrix Application Delivery Management System, which we call it as ADM. It is a centralized management solution. It simplifies operations by providing administrator with enterprise-wide visibility and automating management jobs, application insights, and advanced analytics. You can use ADM to manage, monitor, and troubleshoot the entire application delivery infrastructure. The other offering that we are going to discuss today is with the Citrix Observability Exporter, where we export data to popular endpoints where you build your own do-it-yourself solution. Citrix Observability Exporter is supported for all Citrix ADC deployment types and its form factors. Here we will see two typical cloud deployments. One is the two-tier ingress, where we have the Citrix ADC generally in the VPX form factor, serving your applications north-south traffic, and the second tier ADC generally in CPX form factor, acting as an ingress gateway to your microservice applications, serving the east-west traffic. Citrix Observability Exporter can be deployed in a Kubernetes environment or as a standalone on a Linux host system. For the demos today, we will use the second deployment of Unified Ingress, where your Citrix ADCs serve both the north-south client traffic and east-west microservice application load balancing and traffic management. In this demo, we will deploy your microservice apps on a Kubernetes cluster with Citrix ADC in CPX form factor front-ending these apps. Citrix ADC acts as an ingress gateway to all the client traffic and load balances the traffic across your microservices. CIC is our Citrix ingress controller built upon Kubernetes ingress resource concept, where it programmatically configures the Citrix ADC using Nitro API based on the ingress resource configuration. Citrix ADC, having visibility to the client traffic, will be able to capture and export all the layer 3 to layer 7 information bundled as transaction logs and events and metrics to Citrix Observability Exporter, which then converts it to structured transaction logs suitable for the endpoint that you have configured your COE for. This example is available in our GitHub page under Citrix Observability Exporter, Examples and Elasticsearch. Let us first see some of the YAML files that we have here for easy deployment on your Kubernetes cluster. First, let us see the config map. This config map is defined to indicate your Citrix ingress controller that the Citrix Observability Exporter is deployed in this particular IP or FQDN address, and it needs to make the necessary configuration on your Citrix ADC for the required logs to be exported to the COE. Here we specify the type of data we need to enable Citrix ADC to export, like metrics, audit logs, events and transactions. So for this demo, we'll only enable the transaction, and we'll try the time series data export for metrics in the next example. So let us see the Citrix Observability Exporter YAML file. So here there are three parts. One is the config map for the Citrix Observability Exporter, which specifies the Elasticsearch as an endpoint, the index prefix for the Elasticsearch, and the index interval. So we have multiple options for this: daily, hourly, weekly, etc., that you would find in our documentation, and different types of transaction logs that we would want to export. Here HTTP, TCP, VPN, gateway, and so on. So the second part to it is your actual image, which is deployed on Quay. And the third part is the network related information, where we specify the node ports for Citrix Observability Exporter. So let us see the web service. This is our test microservice app deployed for this particular demo. Now we'll see the Citrix ADC and the Citrix Ingress Controller YAML file, which is defined, which contains both the Citrix ADC and Ingress Controller definitions. If you see here, we have the Citrix ADC image and the Citrix Ingress Controller as a sidecar. So let's go ahead and deploy this particular example. So I have git cloned that particular repository on my machine. So we have all the files here. We'll go ahead and create the deployment. Let's wait a couple of seconds for the setup to be up. So if you see here, we have the Citrix Observability Exporter, we have the CPX or the Citrix ADC with the CIC as a sidecar, we have our Elasticsearch server, we have Kibana, and our microservice sample app. Now as the setup is going to be up in a few seconds, we will see the node port for the CPX ingress gateway. So here we have exposed the port 80 and port 443 as a node port, which we will use to generate some traffic. Let me quickly open up the browser, and with my node IP I will put the node port, and this is our sample application. So let's send some traffic by creating some GET requests. So some GET requests, maybe some POST requests. And let us simulate certain response codes for maybe a post. So let's say we have 404 as a response code, or maybe a 500 internal server error. So with all this data being pushed to the Citrix Observability Exporter, it would convert into the JSON format, and it should have exported to our Elasticsearch. So we will check our Kibana and try to deploy a sample dashboard. So this is our Kibana service. So let's copy the node port and try to deploy that. So Elasticsearch is coming up. So we also have certain dashboards pre-built for just a quick deployment. So we have our Kibana apptrans.json file. I have pre-downloaded it, and let us go ahead and import that. So connect to your Elasticsearch index. So import, we'll select the file and then click on import. So we have our application transaction dashboard up. Let's click and see what we have here. Voila, we have all the data here. So we had sent some 11 GET requests, 6 POST requests, and the response codes we had 200, 404, 500, and all the application content type, say text / CSS, application JSON, and so on. Not only that, we also have the URL information, which says how many, the top URLs with a particular response code, which is 200 to 299. We have response code for 400 and above. We have response code requests for 500 and plus. So we easily can see all the anomalous requests or the requests that failed. We also see the durations that each URL took to load. We have ample amount of data to visualize and fine-tune your application to provide a better user experience. Identify the key issues and build an ML model which could feed into your Citrix ADC to make config changes to support a better user experience. Let me just quickly show you the various transactional log fields available. So if you see here, we have Citrix ADC exported data for all the client and server L3 to L7 traffic information. We have the flow flags, we have the client MSS info, we have TCP error information like jitters, TCP packet train transmit timeout counts. We have the TCP zero window event occurrence count. We have all the HTTP information like the host header, request method, the request forward time to first byte, the timestamp, the request forward receive to last byte, the last byte of response received, your user agent, you have the transaction end time. We also have the transaction start time, request timestamp, and the various flow flags, the TCP jitter information on the server side, all the TCP information. The similar one which we saw on the client side is also available on the server side. So there is a lot of data for us to visualize, create alerts, and to ensure that all the components in your microservice environment is healthy and up. What we have currently seen on the Kibana dashboard was data pertaining to TCP and HTTP. Since Citrix ADC can front-end various application types, we can get tons of information for the various other data protocols. The various fields and the data type and their description is available on the Citrix ADC in this particular file. Here we see the flow flag definition indicating the HTTP version, whether it is an SSL session, if DOS protection is enabled, and so on. We have SSL cert info, the size of the server, client cert used in this connection, SSL handshake related information like if there were any handshake error, the type of ciphers used, and the various SSL parameters. If you enable application firewall on your Citrix ADC, then we also get information about the various attack vectors that your application is protected against, and the type of application attacks that the ADC has helped prevent your application from. If you also have databases in your environment, Citrix ADC can provide insights about your database type, protocol, DB username, query string, the DB response stats, and more. Now that we have seen how the transaction logs of various application parameters exported from Citrix Observability Exporter to Elasticsearch and how we visualized the same on the Kibana dashboard, we will add the Prometheus into this mix and try to get the metric information pulled from Citrix Observability Exporter. So here what we see is Citrix Observability Exporter, as we have seen earlier in the architecture diagram, it runs a push gateway, and the Prometheus is configured to pull data from Citrix Observability Exporter. So the Prometheus scrape target would be our COE. Now the same data is can be visualized in Grafana, create alerts, and so on, which we will see in the demo. So for this example, we will use the YAML file available for deploying Prometheus and Grafana from our GitHub page, and then we will use the similar YAML file what was provided in the Elasticsearch example, but for COE we'll use this particular YAML file instead of the base Elasticsearch YAML. So let us create the Prometheus and Grafana. Okay, let's edit the CIC config map and make the metrics as true. Okay, CPX application. So for this demo we will use the COE-ES Prometheus.yaml file. So let's see our entire setups. Now we have the Prometheus and Grafana on the same setup, and we have our Citrix Observability Exporter with Prometheus enabled. So let us now go and check the Grafana UI. Let's import the dashboard available from our example folder. Okay, import. I have pre-downloaded the file, so let's import. So we'll select the data source and we do an import. Yes, so here we have the Grafana dashboard loaded. So we can see that the metric information that Prometheus is pulling from the Citrix Observability Exporter, and the Grafana dashboard is able to get the ADC health metrics like the CPU, the memory stats, the network data bytes, RX and TX bytes, how the CPU cores are performing, and if there are any network packet drops, the number of GET requests, the TCP resets if there are any, the state of your LBV servers, CSV servers, and the service or the microservice app that the Citrix ADC is front ending. So this is very critical, right? So if any of your microservices go down, you need to have alerts for this and have a mechanism to get the service back up. So we have the application specific health in this particular tab here. So we have number of client connection to various load balancing vServers that you have on your ADC. So we get to know how many clients are connected currently. We also have the number of HTTP requests processed on the observability exporter, and if there are any anomalous transactions like the 5xx transactions that are received. And this particular metric information does not, the Citrix Observability Exporter not only exports all the Citrix ADC metrics, it also exports the application health metrics and its own metrics for you to ensure that end to end there are all the nodes in your microservice environment healthy and your systems are up. So now that we have seen all the data metrics and log information that we could collect from Citrix ADC and the Citrix Observability Exporter, we will see how we can feed these metrics to a horizontal pod autoscaler and improve your application performance and by taking appropriate scaling decision. So as we see here in this blog, we provide a solution where we feed in the request rate per second as the metric to the horizontal pod autoscaler to take decision on your pod scaling. So here we have the Prometheus adapter in addition to the Prometheus to feed in the metric that we have decided, like the HTTP request per second, to our pod autoscaler to scale your pod auto or the microservice application dynamically. From these metric data and the timestamps, we can also map to the actual transaction on your Elasticsearch and kind of get to know, okay, at this particular time with this particular client IP port tried to access, and whether there was a TCP reset or what was the duration it took to load that particular URL. All that information can be intermapped, which is the beauty of observability as a solution. Now that we have seen the two important pillars of observability, that is the metrics and logs, and how Citrix Observability Exporter supports various endpoints to facilitate you to create dashboards and alerts and find out the root issues that you would see in any of your microservice application. It is also important that once you have been alerted of an issue, to trace and identify the root of the issue, where your latency problems are. So to kind of demo this, we'll use Zipkin as the endpoint and see how we get the end-to-end data flow for your application. We have pre-deployed a shopping cart application for watches. So we have multiple pods, namely Fast Track, Sonata, Titan for each watch type. And when the request is coming to the Citrix Ingress Gateway, we would query individual pods and get that information, and also send the tracing information to the Zipkin endpoint via the Citrix Observability Exporter. So let's send some traffic and see the data on Zipkin. So we will first select the service name, Amazon, and then we'll select the span name and then the duration and see the traces. So if you see here, the client request was served by the front-ending SSL vServer, which talked to the Amazon pod to fetch all the watches details. So internally, the Amazon pod talked to the backend microservices app for each watch type like Casio, Sonata, Titan, and Fast Track through an ingress load balancing vServer. So here we can see the duration of the request and how each transaction to each pod took what time to respond. So here we can see the tracing information, which includes the response status, the URLs, the SSL info, the cipher strength, and so on. The important thing to view here is the duration it took to load that particular application page. So we can clearly identify that the request that went to the Fast Track app took more time than the other microservice apps. So clearly we can pinpoint the latency issue that we need to tune by either scaling that particular pod or fixing any application related issues. Logs, metrics, and traces serve their own unique purpose and are complementary to each other. In unison, we have demonstrated how Citrix ADC and Citrix Observability Exporter together provide maximum visibility into the behavior of your application system.